We're going to have a look at a problem-solving gradient question. But before we do, I just want to remind you that when you're doing any kind of calculation that involves measurements, the unit of measurement must be the same. So what I mean is, if you've got a question and it wants you to work out the gradient, and our horizontal is 4 meters and our vertical is 25 centimeters, this one's in centimeters, this one's in meters, so we're going to need to convert them so that they're in the same, so that they're either both meters or both centimeters. So what I'm going to do is I'm going to change the meters into centimeters. To do that, you just times by 100, so 4 times 100 means that that's the same as 400 centimeters, and then we can work out our gradient now that we've got both vertical and horizontal in centimeters. Now you could get that in a non-calculator question and it could ask you to simplify it, so you would have to simplify this fraction as far as possible. You could do that by dividing both by 25. So 25 divided by 25 is 1, and 400 divided by 25 is 16. So the gradient of that ramp is 1/16. Now we're going to do a problem solving question. So we've got a walkway bridge is built to connect two buildings shown in the diagram. So this is the bridge, and we've got a building on this side and a building on this side, and this bridge is connecting the two buildings. Part A says calculate the gradient of the bridge. Now, usually when we are doing gradient questions, they are triangles. This shape is not a triangle, so we need to be careful that we are looking to create a right angle triangle on the drawing. So if I draw a dotted line here, that creates a right angle triangle with the slope that is the bridge and the two sides. Now this dotted line is the same length as the horizontal distance along the bottom, but we also need the vertical distance of the right angle triangle. Now we know that this whole side is 15 meters, and we know that from here to here is 10 meters. So what we can do is do 15 take away 10, and that would leave us with the vertical distance that we need. So 15 take away 10 is 5 meters. Now that we've got our vertical and our horizontal, we can calculate the gradient of the slope. So we end up with 5/20, and we can simplify that by dividing by 5, and we end up with 1/4. So the gradient of the bridge or the walkway is 1/4. Now part B says calculate the length of the walkway. So that means they're wanting us to calculate this sloping edge. So we do have a right angle triangle that I'll quickly draw out. So I've just taken this bit and drawn it down here. And we are trying to find the side that's opposite the right angle, which is the hypotenuse, which is the longest side. So we're just using the normal Pythagoras formula, c² = a² + b². Put in the numbers, pop it in your calculator, and you get 425. Square root both sides, and you should get 20.615. It keeps going. I'm just going to round it to one decimal place, so 20.6, and it's meters. Now, part C says safety regulations state that the gradient of the ramp has to be 0.2 plus or minus 30%. That's supposed to say 30%. So we need to determine if the ramp is safe. Now we've already worked out the gradient further up in the question. It was 1/4. Since they've given their gradient as a decimal, we're going to change that quarter into a decimal. So top divided by bottom, so it'll be 0.25. So all we've done is 1 divided by 4. Oops. So our gradient is 0.25. We need to determine if that lies within this tolerance. Now, remember when we did tolerance, you're allowed anything in between the maximum and the minimum value. And we've been told that the maximum value is 0.2 plus 30%, which means we're going to have to work out what 30% of 0.2 is. And to do that, we just do the percent divided by 100 times the amount. And we should get 0.06. So our maximum value is going to be 0.2 plus 0.06, and our minimum value is going to be 0.02 take away 0.06. So we should get 0.26 for the maximum and 0.14 for the minimum. Now we need to decide, is 0.25 in between these two numbers? And if it is, that means the ramp is safe. So 0.25 does lie in between these two numbers, so the ramp is safe. And you would just write a sentence at the end to answer the question.